Hello everybody, welcome back to another A-Red Stuffy video. I know it's been a long time for a calculus video. We're doing calculus today, but we're just going to hop right into it. So today we're going to be focusing on double integrals. So as we can recall, in single variable calculus, we had an integral, looks like this. It's just a function of one variable, boring, boo. And the graph looks something like this, you got your function here over this interval. Boring, one-dimensional, not cool, not very cool because it's one-dimensional. So this is single variable. Disgusting. No one likes that, except people who do like that. Alright? Now if we go to multivariable, that's where we get double integrals, function of two variables. So let's say, for example, let me erase this. So let's say, for example, we have a function z equals f of xy. So let's have our graph here. So let's say it looks something like that here. And this is just z equals f of xy. Okay? Now, what is a double integral, you may be asking? Well, a single integral is the area under the curve. Now, a double integral is the area of the region under this graph f of x, y, okay? So that's what it is. But how do we notate it? So let's say this region is R. Now, there may be different expressions for R, maybe V, A, a whole different things, but we're going to stick with R because it makes sense. Region R, hopefully. So how do we notate this? Well, a double integral is pretty easy to notate. It's just two integral signs. How creative of this region R of f of xy dA. Now you may be asking, what is this dA? Well, now this dA is a piece of area inside of it, okay? And we'll see, I'm not going to go into the full derivation to this, but this dA is just split up into dy and dx, okay? So I'll just make a quick little picture here. So if we see this is just, something random. So a piece of this area, in this region R. So let's say this point right here, this is xi, yi, and to actually get this, you take the sum of all these things, and then take the limit of it. Okay. Now it's a whole different process. It's a whole big process. If you want the derivation of it, I recommend MIT's 1802 lecture 16, which actually goes through the whole derivation. But I'm here just to teach you the basics. Okay. No one wants to watch a 50-minute lecture. Okay. So seems straightforward. Seems very straightforward. All right. Where do I want to? Okay, let's actually do an example because hopefully this makes sense. Should make sense. Oh, another thing. Double integrals cannot be anti-differentiated. They always have to have this region R. Okay? With the first single variable, you can have antiderivatives. You can't get an antiderivative here. It wouldn't make sense. Okay? Just wouldn't make sense. Partial derivative, it doesn't make sense. I don't want to think about it. So let's do an example. Okay, so let's say we have a function z equals 1 minus x squared minus y squared. Okay. Now let's just graph this just to get how it looks. Just if you haven't watched my video, actually I haven't made a video about this. If you want a video on graphing three-dimensional functions, just let me know in the comments. Okay, so this is region R here that we're looking for. Okay. Now, let's say this region is between 0, let's say 0 and 1. All right. Now, the trickiest part usually about double integrals are actually setting up these bounds, because these are always this is the most tricky part. Okay. Because you can't. Well, one way, if the bounds are set up one way, may be easier or harder to integrate. And I'm just teaching you the basics. Next video, hopefully, we'll actually get on the how to switch bounds, right? So we can notate this as like this, of 1 minus x squared minus y squared dy dx. Okay. Now this dy dx is pretty much this dA here. Okay. Now we got lucky. In this example, these bounds can be flipped, and it wouldn't make much of a difference. But yeah, all right. So let's actually integrate this. Well, this is called an iterated integral. All right. So we can integrate this section first, and then integrate that integral. Okay. That's called so this is like s of 0, s of x 0, and then we integrate s of 0 s of x 0. That makes sense. Okay. So if we integrate 1 minus x squared minus y squared, we have to pay attention to what we're integrating, what respect we're integrating to. So in this case, we're doing y. So if we integrate this with respect to y, 1 minus x squared minus y squared, we'll get the integral of 0 to 1. Remember, having the integral outside because we're just taking this. Now, integral of 1, that's just y, minus x squared, we're keeping that x squared there, minus 1/3 y cubed, okay? And then we plug in our bounds, 0 to 1. That is 1 minus 1/3. Am I correct? Yes, 1 minus 1/3. So it gives 2/3, all right? Am I correct here? Let's check. Yes, I'm correct. So we'll get, we can expand that. We'll get 2/3 x, 2/3 minus x squared. Now we take the integral one more time of now with x, and that will be 2/3 x minus 1/3 x cubed. Okay, and now we'll plug that in. We'll get 2/3 minus 1/3, thus resulting in 1/3 as our final answer. So if that's the final answer. Whenever you have a double integral, you always get a answer, okay, a real number answer. All right, so that's just the basics of it. Pretty simple, but it'll get more complicated. Don't worry. So hope that video helped you. Hope it helped you, entertaining maybe. I don't know. You watch these for fun, and then make sure to leave a like, comment, subscribe. Have a great day.